Okay, in this, hello everybody. This time we solve some electric field problem. We have two plates given. One is loaded by plus charges, okay. The other is with minus charges. So we place two charges inside these plackets. Okay, so one is minus Q1, the other is plus Q2. So they say that the distance between the two charges is point, this is x, 0.34 meters or 34 centimeters, and the distance between the two plates is given by L, but probably we will not need this distance because they say that the electric field between the plates is given as 73,000, okay, newtons per coulomb. So it's a big electric field. It can only be obtained by applying a high voltage. That's okay, but we don't need to know all these details. So the question is that find the force on Q1. So find force on Q1. Okay, so we would like to find the force on this charge. So let's place this again. So we know that because this is plus and minus, there is an electric field in between, and it must be this way. So we call this as E plate, okay? We call this electric field as E plate. Okay, and what about these two charges? Because now, this is minus, by the way. This is minus Q1, and this is plus Q2. So now, since we are interested in the total field at this point, we don't consider this charge, but consider everything else. As you see, at this point, there is an electric field to the right. Okay, so this is E plate. E plate. But now, look what happens. Because this positive charge produces electric field this way, everywhere, okay? And also in this direction, it will produce an electric field, and this will be just E2. So E2 will be to the left for this charge, minus charge, okay? So this is the electric field that is obtained. Now, in order to get the electric field, we really don't have to consider this charge there, okay? Because we are just solving the electric field, and whether this charge is negative or positive really does not affect the fact that the total electric field is obtained from the effect of these plates and also the effect of this plus charge. So basically, whatever one is greater, then the net electric field will be in that direction. So this is what we have to do. So first, let's solve, because E plate is given. So E plate is given as 73,000 newtons per coulomb, okay, or F equals QE, don't forget. So the dimension of electric field is either newtons per coulomb or newtons, okay, per coulomb, or in terms of voltage that we will see, volts per meter, whatever. So since we didn't see this chapter yet, so we are using now newtons per coulomb. So this is the equation that we use. Of course, we have to use capital Q because we named the charges as capital Q. So to get the force, all we have to do is multiply whatever charge is placed at this point, which happens to be Q1, okay? So now the plate, between the plates, this electric field is given by this. And what about E2? E2 is the electric field arising from this Q2. So E2 is just then K Q2 divided by R squared, but distance is X, so it's X. So the distance between the two is given by X, and X is given. Okay, so they say that also the charge Q2 is 1.3 microcoulomb, and this charge is given as, okay, 6.7 microcoulomb. So they also give the charges. So now K value is 9 times 10 to the 9, okay, so K, 9 times 10 to the 9, and the unit is the unit of electric field times meter square divided by coulomb, whatever, but we don't need to write the unit there. So electric field will be, due to this second charge, will be just 9 times 10 to the 9 times Q2, which is just given by 1.3. Micro means 10 to the minus 6 divided by the distance squared. The distance is given already in meters, so it's 0.34 squared. So when we solve this, we find that electric field is just 10 to the 5 or 10,000 newtons per coulomb. Okay, newtons per coulomb. So now, which one is greater? Of course, 73,000 is greater than that, so that the net electric field will be to the right or to the left. We have to find out. Okay, so 10 to the 5 is 100,000, by the way, not 10,000. So that this is greater, so that electric field will be to the left. So net electric field will be equal to 73,000. So where did it come from? Because here the electric field is in x direction, of course, E plate minus E2. Why did we take this plus and then this minus? Because this is positive x direction and this is in positive x direction, this is negative x direction, so that the second one is negative. Okay, so E net will be equal to 73,000 minus 100,000. Okay, 100,000, 10 to the 5, and it will be, okay, just 28,000, okay, or 22.8 times 10 to the 4 newtons per coulomb to the left, okay. So if we want to write this in vector form, E net as a vector form is minus 2.8 times 10 to the 4 I unit vector. So this is the result. So don't forget, if you put a unit vector on the right hand side, you have to also write the vector sign above this left vector. Okay. So now, having found the net electric field, we can get net force. Then the force on this charge Q1. Now we have to use Q1 because F is Q1 times E net. Of course, the direction will be also in the direction of the electric field. So the force on charge 1 will be to the left, net force. Obviously, because this is minus, this is plus, and it goes to the positive plate. Okay. So now, let's write this is here, E plate minus E2 here, so that I have a little bit more space there. Okay. So the force now will be given as, we don't need to write the vector signs because we know the direction is just Q1, but Q1 is given as 6.7 microcoulomb, meaning 10 to the minus 6 coulomb times net electric field, which is 2.8 times 10 to the 4. Okay, so when you multiply, you get the force as 0.19 newtons. Okay, so now maybe in another part of the question, find the acceleration of this charge if the mass is given. Of course, since this is equal to ma, the acceleration is found by 0.19 divided by the mass, whatever the mass is given to you, and then maybe what is the velocity after it, just before it strikes the right surface, left surface. So you can use v squared minus v0 squared equals 2ax, the distance. Okay. So distance, in order to solve this, of course, L should be given to you because the distance to hit the left surface will be L minus x in this case. So the distance for this one, we have to write L minus x, okay? So anyway, since this is also going to be 0, the striking velocity can be found from this expression. This is the combination with PHYS101. Okay, now this problem is solved.